Okay, here we go. I want you to know, this is, what's today's date?
11.
December 11th, 2013. I have a class, a very mixed class. This is my Arab section, okay? Oh, sorry, I have two Arab sections. I know, I don't even want to go there, okay? All right? And I have the side of the class that's always smiling, and that's Jaffer. He's like, always smiling, you know? I'm going to imitate Jaffer really sad, okay? Really sad. All right, you ready? You ready? Okay, this is Jaffer really sad. Okay, I'm doing it. You ready? Right? All right, he's such a nice guy. Okay, he's always happy. Okay, let's begin before I get myself in complete trouble here, okay? Yeah? Okay, so this is, yesterday when I did a type 3 projectile motion problem, it was kind of sloppy. I was all over the place. So what I'm going to do today is, because it's on film and you could always rewind it, as I discover something, I'm going to make a list and then erase the work that I did to come up with the answer. Okay? So let's start here. This is not going to be drawn to scale. And I'm going to show you how difficult it is to draw to scale, because in projectile motion, in ballistics, the initial motion of the projectile is always very, very large. It's always very, very large. And let's say we use 1,000 meters, which is in terms of being a peak from base to summit is quite high. But as a result, it's going to go much higher than the elevation in which it starts at. Okay, so let's go like this. Is that on the board? Is that on the film?
Yeah.
Okay. So that's our area that we're going to work with, okay? And we're going to take a projectile, and we're going to do it at 60 degrees. And we'll take about, did I do 60 degrees last time? I think I did, didn't I? Or I did 45. Well, whatever, we'll do 60. And we'll take a convenient velocity. And we're going to say it's 1,000 meters per second. And that is V naught. In terms of your equation, let's do some work here and really establish this problem. Remember when we had the triangles in the beginning of the year, and we said that this was Y, this was X, and this was H. And in some of your equations, I said VH equals the square root of V squared plus Y squared. So I often said that the initial velocity was VH. Somebody took a quiz yesterday and was a little confused with that. Yeah. So VH and V naught is the same thing. The idea is, when I give you projectile motion, I oftentimes will give you what you might consider the resultant. And then you have to work backwards to resolve it for X and Y. Now, we've been doing that for so long, it should be very much second nature. Because as you know, if you take out your equation sheet, certain equations you're going to know, and you're not even going to have to reference, such as these. V naught cosine theta is your X component, Vx. And V naught sine theta is going to be your Y value, or Vy. Okay? So let's do that right now. This is your hypotenuse, 1,000. So what I want to do right now, and I'm not going to make a big deal out of this, is I want to write down Vx and Vy. So those are our first values we're going to work out. Okay, so what is 60 cosine, 1,000 cosine 60? Yeah, it's going to be half, remember? In 60 degrees, cosine is half. Sine is 0.866-ish, right? Mm-hmm. And then for 30 degrees, it's reversed. Okay? So this is going to be 500, is that right? Mm-hmm. And this is going to be 866? Yeah. 867, 866? Yeah. You have, what's the problem?
Calculator, it's like negative 952.
Okay, did you change, you got to change the degrees? Okay. So this is 866, is that correct? Okay. Now, you got to keep me honest. If I make a typo, you got to point it out to me. I don't want to complete a film with a mistake on it. Okay?
Yeah.
Yes? So, that's the Vx and the Vy that's written there. Okay? Now, what is the path of the projectile called? It starts with a T. What is it? Trajectory, yeah. So it's going to go like this. It's going to go like that. Nice arc, nice parabolic arc. Yeah. Now, this is what we ultimately want to find. We want to find how far it went. We want to find how far it went. Well, if you shoot a projectile high, you're going to have a problem with what? Not with gravity, but with the winds and things like that. So, the higher you shoot this, the more you're going to get into air currents. So, when you're shooting a projectile, knowing how high it went is sometimes important. Not always. The distance is important. So what I want to find is three things. I want to find this height. We're going to call that dy total. And I want to find this distance. And we're going to call that dx total. Is that on the board? Is that on the screen? Excuse me while I check.
Yeah.
Okay, excellent. Okay, we're just on the board. Okay, now, so that's what I want to find, those values. Now, I'm going to erase that marking so we can have some room to do calculations. I don't want to get sloppy. Okay? So what we're going to do is we're going to find the range, the distance, the x value, the total distance, and the total height. Now, you'll see that this problem partly looks like a what? A type 2 projectile motion. And to get the time it takes to rise up to here, we don't call this Ty now in type 3. That's called what? Do you remember from the last problem we did? It's called T1, right? This is going to be T1, and this is going to be T2. Correct?
Yeah.
T1 is the time it takes for this projectile to get to here, and we know that that's going to be related to the equation because what's going to be the final velocity? It's going to be this equation. Vy equals what? V naught T, right? Plus what?
Half.
What's it going to be? What's the equation? Do you remember?
Is it like plus 2a
No. Well, what's the equation for this?
plus 1 gt squared?
Yeah, plus half gt squared.
Let me see your equation sheet. Is it written there?
Yeah. Here.
Excuse me. Okay. Yeah, that's ultimately correct, but isn't it going to be the value? Is that correctly written there, that T? Do you see that yet or not? What's the equation? Remember there are three equations which help you determine all of the motion. Right? What are the three equations? Let's erase this and review this first. Let's erase this and review the three equations. What are the three equations that I said are paramount in figuring out any of this? Isn't it going to be Vf squared equals what? V what?
V naught squared plus
V naught squared plus 2AD, right? Remember that?
Yeah.
What's the other one?
VF
Vf equals
Vf
equals V naught
V naught
plus
plus
A.
AT.
plus AT. And what's the other one?
D
equals V naught
T
T
I
plus
half A T1 squared.
We have a visitor. Yes, Professor Nair.
I need your help if you can.
Okay.
Do you have a time where these guys?
Yes,
can
we will do
work?
that, and I'll come over.
Mr.
What I want
Nair, someone's
Okay.
acid spilled.
Okay.
spilled acid.
Okay. All right. We have a slight emergency here, but that's okay. After this video, no, I'll continue to do this. This is almost over. Okay, so these are the three equations, right? Yes, do you remember now? Now, what equation do you use? What equation do you use to find Ty? Want me to help you?
Wait.
Want me to help you?
Wait.
V final.
We define.
We're talking about Vy, right?
Yeah.
V final equals
V naught plus AT.
V naught
Ty.
plus what?
AT.
AT. Isn't the VF, isn't that the final? Isn't that going to be 0? When this vector rises at 866 meters per second, correct? So when that rises, the final velocity is going to be 0, correct? So that's going to equal the initial velocity. I'm going to leave off the unit labels. Is that okay?
Yeah.
Yeah. And it's going to be subtract off what? Subtract off 10, because it's actually plus, but it's a negative 10 because you're rising, okay? I know the books often say that up is positive. I just don't like that, okay? And then what's t? We don't know t, right? So isn't that what we're solving for?
Yeah.
Subtract this from both sides, you get 866 equals minus 10t. What happens to the minus signs? They drop out, and t equals 87. Yes?
Yeah.
I want to try to round off the values. Yes, we have a question. Excuse me? Yes, you can use the, yes, of course. One of my students is very conveniently saying, can I just use the equation Ty or T1, Ty, which is T1 here, equals Vy divided by G? Yes, of course you can. But what I was trying to do is oftentimes, and I had a student yesterday, and this is very important to understand, especially if you're somewhere else other than the wonderful country of the UAE. And that is that oftentimes these problems become so routine, you don't even realize what you're doing. I had a student yesterday who for whatever reason, they thought 60 degrees was 45 degrees was 60 degrees. It was kind of weird. So if it's 45 degrees, what do you automatically realize? That the Vx and the Vy are going to be equal. Well, they didn't see that because the problem was so routine that they just missed that. So the answer to your question is, of course you can use this equation. But I want you to understand where it comes from, because if you don't understand where it comes from, you will be very likely to make a mistake, because this will become routine. And that's a good thing. That's because you've learned something. But don't allow that routine to cloud your judgments in terms of estimating whether or not the answer you get is correct. Each step along the way, and the final answer. Clear? Okay, so we know that Ty, T1 here, is going to equal 87 seconds. Correct? 87 seconds, correct? Okay, now there's something I didn't give you, and that is this height is dy1. Okay, if you're going to have the initial velocity and you're going to have the angle, you're going to need the height of the mountain. And in this case, it's 1,000. So that's going to be important. Is that that's on the film, right? Okay. So now we have Ty1, we have Vx and Vy. Now what can we determine now? dy2. dy2 is this value here. And then dy total will be that value plus the 1,000, correct? Yeah. Now, think of it like this. Okay. The projectile is there. What's its velocity? 0, correct? Now, pretend it's going to simply fall to earth. It's going to do that. It's going to come to right here, correct? It's going to go from there to here. But dropping from here to here, isn't it the same as going from here to here? Isn't it the same? Yes or no? Yeah, it's the same. So can't you use a shortened equation? dy equals 5 t1. How did I get that? dy equals what? v naught t plus 1/2 at squared. This drops out because the v naught is 0. It's falling from a 0 velocity. So you get dy equals 1/2 gt squared. Correct? G is 10. 1/2 of 10 is 5. So this becomes simply dy equals 5 and then t squared. What's t? Isn't it t1 in this case?
Yeah.
Yes. t1 squared. So dy is going to equal, what is 5 times 87 squared? What is it?
38,345.
All right, so now we have
37,000.
dy2.
Yeah.
All right, I need a
37,845.
37,842
800.
meters, is that correct?
5.
5? 45? Is that correct?
Yeah.
Okay, so do you see that this is not drawn to scale?
Yeah.
This is 37,000, that's 1,000, so it's not drawn to scale, is it? Now we can write dy total is going to equal what? 38,845, and that was what? That was what Jeffrey said, correct? Isn't that what you were referring to when he said 38,000?
Yeah.
Okay, so now what we have to do is we have to find this distance. I'm going to shut off the video, okay, and I want you guys to find dx1, dx2, and then dx total. Okay, clear?
Yeah.
And then we're done. So let's turn off the machine, come back, we'll call this whatever it is, we'll put the date on it, we'll say part 1 and then see part 2. Yes?
Yes.
Okay.